one of the presenter of Group 6. Before we start to present our report, I am going to introduce each member of our group. They are Ryan Abejo, Glenn Dapucanta, Kenneth Quindiob, Lablea Tablate, and Arvin Bulagay. On the other hand, there are 3 assigned topics to us, which are Horton model, Phillip's equation, and the Green-Ampt model that we will explain later. So for now, just take a seat, relax, and watch our report video presentation until the end. Because we assure that this report video presentation is worth it to watch. Never mind that. I am the one to explain our first topic, the Horton model. Its contents are Horton model meaning, concept, formulas used, and the sample problem. So, shall we start? The Horton method describes how infiltration capacity declines as the precipitation event advances and is based on generating runoff when rainfall intensity exceeds the infiltration capacity. In addition, the modified Horton's equation describes the recovery of infiltration capacity during dry periods. Dagdag ko lang pala dito ay yung Horton's equation kasi ay isa ito sa viable option when measuring ground infiltration rates or volumes. So sa next slide, aalamin natin kung sino nga ba si Robert Elmer Horton. Horton was an American civil engineer and soil scientist, considered by many to be the father of modern hydrology. Si Robert Horton ay sa kanya nga galing ang Horton infiltration model o bunga ito ng kanyang pag-aaral at pananaliksik na kung saan dito niya nalaman ang relationship na physical features ng drainage basins at yung pag-agos ng tubig on and beneath surface. Bukod dito, kilala rin siya sa kanyang teorya na nag-uugnay sa infiltration of soils to the generation of floods by surface runoff. Sa next slides naman, malalaman natin kung ano nga ba ang Horton's infiltration concept. Dito sa Horton's infiltration concept, papaliwanag ko kung ano-ano nga ba ang nilalaman ng Horton's model. Doon muna tayo sa F sub O. Ito yung nakabold na curve line na tinatawag na Horton infiltration capacity curve. Kung mapapansin natin ay pababa yung kabilang dulo ng curve na nagre-represent na kapag ang lupa ay napuno na ng tubig ulan ay nare-reduce ang capillary suction nito. Next is ay yung initial loss to storage. Ito naman yung mga ulan na hindi nasisipsip ng lupa o nag-evaporate dahil nga sa init ng lupa. At pwede rin dito yung mga patak ng ulan na nasa dahon ng mga puno o damo na tinatawag na canopy interception. Yung volume of runoff naman ay siya yung nagpo-flow sa land surface natin papunta doon sa streams na eventually pupunta doon sa ocean. Pang-apat natin ay yung volume of infiltration. Dito naman natin mina-minus yung precipitation na nagstay sa mga puno. Siyempre, may mga formulas para dyan. Lastly ay yung infiltration rate. Ito ay yung pagsusukat kung gaano ba kabilis mag-enter yung tubig sa lupa. Karaniwan itong ina-express in inches per hour. Ngayon naman ay tutungo tayo kung ano nga ba ang Horton's equation. It is an empirical formula that says that infiltration starts at a constant rate and is decreasing exponentially with time. After some time, when soil saturation level reaches a certain value, the rate of infiltration will level off to the rate. At ito yung formula na gagamitin natin sa Horton's equation. So F is equals to F sub C plus open close parenthesis F sub O minus F sub C times E raised to negative K times E. So dito sa formula, ang hahanapin natin ay yung F o infiltration capacity. Ang infiltration capacity kasi ay siya yung sumusukat kung ilang inches ba ang kayang i-accommodate ng soil sa isang oras. At base nga sa formula, yung F is the infiltration capacity at some time t. So yung F sub O naman is the initial infiltration capacity or maximum infiltration rate. Yung F sub C naman is the final infiltration capacity or equilibrium infiltration rate after the soil has been saturated or minimum infiltration rate. At lastly is yung K. K is an empirical constant that says something about how long it takes for rain to force the soil from its initial to its final infiltration capacity. Ngayon, para mas maintindihan pa natin yung patungkol sa formula sa Horton's equation, magbibigay ako ng sample problem. The initial infiltration capacity of F sub O of a watershed is estimated as 1.5 inches per hour, and the time constant is taken to be 0.35 R raised to negative 1. The equilibrium capacity of F sub C is 0.2 inches per hour. Use Horton's equations to find. So, may dalawa tayong questions. So, first is yung A, the values of F at T. So, T is equals to 10 minutes, 30 minutes, 1 hour, 2 hour, and 6 hours. For the B, the total volume of infiltration over the 6-hour period. Doon muna tayo sa question A. So, what are the values of F at T is equals to 10 minutes, 30 minutes, 1 hour, 2 hour, and the 6 hours. So, may given na dito yung F sub O, F sub C, and yung K. Pagkatapos nito, i-apply lang natin lahat ng mga given sa formula ng Horton's equation. At yung given na time ay i-convert lang natin yung minutes into hour. Pagkatapos nun, direct input na lang natin sa calculator and then makukuha na natin yung sagot. Kaya hindi ko na sinulat dito yung ibang solution katulad ng 1 hour, 2 hours, and yung 6 hours kasi nga ganun din lang yung process ng pag-solve. At kung tapos na tayo mag-solve, ito naman yung lahat na kabuuan ng sagot. As you can see on F inches per hour, as the duration continues, is nagdi-decrease yung infiltration capacity. At yung sa baba naman na nakabox, ay makikita natin yung curve representing infiltration by that particular equation. Ngayon naman, pupunta tayo sa ikalawang question, yung letter B. To get the total volume of infiltration, ang gagamitin nating formula ay F is equals F sub C raised to T plus open close parenthesis F sub O minus F sub C over K times 1 minus E raised to negative K times T. So gamit ang formula na ito is makukuha natin ang sagot na F is equal to 4.46 inches. And that is all about the Horton model. Next topic is Phillip's equation that we will explain by Lablea Tablate and Kenneth Kin Diog.
Hi everyone, my name is Kenneth Kin Diog from Group 6, and for today's video, we're going to talk about Phillip's equation. Let's start. Phillip's equation of 1957A, for case of vertical infiltration, Phillip's solution of Richard's equation was of the form of physical-based converging power. Series which describe cumulative infiltration as a function of time. Cumulative infiltration is equals to S times T raised to 1/2 plus quantity of A sub 2 plus K times time, and so on. Phillip's equation of 1957B, Phillips showed that truncated or yung mas pinaigsi but it does the same form of the previous equation with just two fitting parameters is sufficient for all practical purposes to describe the time depends of cumulative infiltration. Cumulative infiltration is equals to S multiplied by T raised to 1/2 plus AT. So for third slide, makikita natin yung two equations. So S is equals to sorptivity, A terms is equals to transmissivity, K is equals to hydraulic conductivity, and T is equals to time. So, punta tayo sa fourth slide. The transmissivity term in the previous equation has dimension of L raised to negative 1 and reflects the soil ability to transmit water under the influence of gravity. According to Dunin, transmissivity is related to the soil's saturated hydraulic conductivity. Phillip's equation 1969. Phillips observed that for long intervals for which the infinite series of equation does not converge, the equation of cumulative infiltration is equals to S multiplied by T raised to 1/2 plus A multiplied by T can be approximated by cumulative infiltration is equals to S multiplied by T raised to 1/2 plus K multiplied by T. Next reporter po.
So this is the continuation of our report in Phillip's equation. Now this is the Phillip's equation for cumulative infiltration. By differentiating that, we'll get the infiltration rate. The sorptivity term reflects the soil's ability to absorb water by metric forces during the initial stages of the infiltration process. For a horizontal column of soil, gravity effects are considered negligible and the contribution of the K times T term is also negligible. So the formula for the cumulative infiltration in a horizontal soil column is reduced to this one. So now we have our example. A small tube with a cross-sectional area of 40 square centimeter is filled with soil and laid horizontally. The open end of the tube is saturated, and after 15 minutes, 100 cubic centimeter of water have infiltrated into the tube. If the saturated hydraulic conductivity of the soil is 0.4 centimeter per hour, determine how much infiltration would have taken place in 30 minutes if the soil column had initially been placed upright with its upper surface saturated. Before we solve for the cumulative infiltration in a vertical soil column, we must find first the absorptivity because the given are just the hydraulic conductivity and time. For that, we use the Phillip's equation in horizontal soil column. Cumulative infiltration equals to S times T raised to 1/2. The cumulative infiltration is the water that I've infiltrated over the cross-sectional area of the tube equals to S times time, which in our raised to 1/2, simplifying that we get the 5 centimeter times place the negative 1/2. Now you have the value of sorptivity. You can now solve for the cumulative infiltration in the vertical soil column. Cumulative infiltration equals S times T raised to 1/2 plus K times T. 5 times time, which is in our hours, that is to 1/2 plus the hydraulic conductivity times time. Now we get the cumulative infiltration of 3.75 centimeters. So that's it. Thank you.
Hi, my name is Green-Ampt. I am the first presenter of Green-Ampt model, and I'm going to explain Green-Ampt method in analyzing infiltration. The Green-Ampt model is a simplified representation of the infiltration process. It assumes a homogeneous soil profile and a uniform distribution of initial soil water content. Green-Ampt infiltration. So, ang infiltration ay nangyayari sa ilalim ng lupa. Meron tayong dalawang flows, saturated and unsaturated flows. Ang saturated is walang space na hangin sa baba ng soil. Puro tubig na lang ang nagfo-flow sa pores or void ng soil column. And ang unsaturated naman is yung ibang mga pores or void ay merong hangin at merong tubig. Ang ginamit nilang equation dito upang i-represent ang unsaturated flow is Richards equation and Darcy's law. So, Richards equation. Change in moisture content with respect to time is the function of hydraulic conductivity and suction pressure and then elevation. So, meron tayong mga parameters or variables. So, delta is equals to volumetric moisture content. Z, distance is equals to distance below the surface. Capillary suction or pressure suction. K is equals to unsaturated hydraulic conductivity. So, sa Darcy's law, Q is equals to negative K times delta times change of hydraulic head over change in elevation. So, mayroon din tayong mga parameters. Q is equals to Darcy velocity, Z is equals to depth below surface, and H potential or head, and suction negative centimeter. Ang K is equals to unsaturated hydraulic conductivity, theta volumetric moisture content. 5 principal assumption of GE method. The soil under consideration is homogeneous and stable, implying that macropores and preferential migration pathways should not be considered. Number 2, the supply of ponded water at the surface is not limited. Number 3, a distinct of precisely definable wetting front exists, and as water continues to infiltrate, the wetting front advances at the same rate with depth. Number 4, the capillary suction just below the wetting front is uniform throughout the profile and constant in time during the infiltration event. Number 5, the soil is uniformly saturated above the wetting front, and the volumetric water contents remain above and below the advancing wetting front. Meron tayong example ng wetting front. Makikita dito yung dry soil and yung basang soil, and then yung simplification ng Green-Ampt method. Makikita dito yung infiltrating water, saturated soil, wetting front moves down into dry soil, and wetting front matrix suction pulls water into dry soil.
My name is Ryan Isabel. I'm the one of the presenter of Green-Ampt model, and I'm going to explain the method of simplification and the method of derivation. Method simplification. First equation is table is moisture profile of moment of surface saturation, and the second is moisture profile at a later time. Next is method derivation. Downwards infiltration is equals to negative F is equals to Darcy velocity Q and unsaturated soil. it is a method of derivation. 3 parameters specify depends on the pore size and grain size of properties. Next is difference between the atmosphere and hydrostatic pressure. MD is function of effective porosity and initial saturation. Tapos ito po yung volume of infiltration at a surface saturation. We require greater case is remember what capillary sanction. The Green-Ampt infiltration method will predict the following insult in various intensity rainfall. Ito po yung example of the problem. For the following soil properties, develop a plot of infiltration rate versus infiltration volume F using the Green-Ampt equation.
And that's it. So we hope that you gained knowledge about our report, the Horton's model, Phillip's equation, and the Green-Ampt model. And thanks for watching again.
Behind closed doors, I'm a fool for your love.